Hi everyone, I'm Ethan Santos and I'm joined by my team Mary McNeil, Matiana Lang, and Christian de Guzman. And our project is UV Clean, the autonomous UVC sanitation robot. Currently, we are limited to using cleaning products that use harsh materials and require many hours of physical labor while still not effectively sanitizing our environments. Our team proposes a UVC device that will drastically improve our sanitation methods.
Ultraviolet light, or UV light, describes a specific range wavelength of light. UVA and UVB are the ranges of light that reach Earth from the sun. UVC has a smaller wavelength, giving it germicidal properties. When applied correctly, germicidal UVC can kill pathogens and prevent the spread of disease. Take, for example, a common bacterial cell. UVC light is able to penetrate the bacteria and destroy the hydrogen bonds holding DNA base pairs together. With the hydrogen bonds destroyed and the DNA base pairs no longer connected, the cell cannot perform vital functions to stay alive and dies. With the cell dead, it can no longer replicate and spread, and therefore prevents further spread of disease. This is a figure illustrating the effects of UVC light on DNA before and after the breaking of hydrogen bonds and DNA base pairs. Our device offers a more accessible and easy-to-use method for sanitation. By using UVC light, our system is able to efficiently sanitize surfaces and rooms, saving time and manual labor. It simply moves throughout the room autonomously, sanitizing as it goes. Our device is also small in size, lightweight, and rechargeable battery operated, allowing for high mobility and making it easy to transport between rooms. Most importantly, our device is safe to use with various safety mechanisms, such as motion detection sensors and a complementary app that offers remote turn-off capabilities. This is what a full cycle completed by UV Clean looks like, which is defined as the sanitation of one full room. Once the battery is finished charging and UV Clean is turned on, the robot starts a diagnostic state, checking the battery level, the temperature of the components, and ensuring the robot is capable of completing a full sanitation cycle. The user can decide which mode to set the robot in, either small room mode or large room mode. Determined by flipping a switch, the robot will enter the desired mode and efficiently complete its sanitation cycle. Once the sanitation process is complete, UV Clean sends an alert to the user via the Bluetooth app, and UV Clean waits in low power mode to conserve battery power. If the user does not come in to turn it off within 5 minutes, UV Clean goes to sleep in ultra low power mode. If there is ever motion in the room during the sanitation process, UV Clean alerts the user via the app and immediately shuts off the UVC bulb to ensure user safety. As mentioned, UV Clean has two different modes of sanitation in order to properly sanitize an average-sized room. Small room mode is catered towards rooms that are smaller than 12 feet by 12 feet. During this mode, UV Clean remains stationary and runs for 11 minutes. Large room mode is the second mode of sanitation that is tailored to rooms that are 12 feet by 12 feet. Here, UV Clean will autonomously navigate around the room, following the perimeter of the room from a distance of 3 feet. Every 3 feet, UV Clean will stop and remain stationary for 2.5 minutes in order to sanitize the surrounding area. As mentioned before, large room mode requires autonomous navigation. Our device is fitted with ultrasonic sensors, which allows UV Clean to sense its distance from objects in the room, such as walls and furniture. This is the layout of the sensors on UV Clean. There are 4 sensors placed around the robot, which are located on the front, right, front left, and back left of the robot. With these sensors, the robot is able to detect obstacles and avoid them as it navigates around the room, assuring it effectively sanitizes the entire room. For efficient movement, our device has a 2-wheel drive system with a left and right wheel. These wheels are controlled via motors with encoders, allowing our robot to turn, drive, and navigate precisely while completing its cycle. These two figures illustrate the navigation path of UV Clean in large room mode. The left figure shows the path without obstacles, while the right figure is the path with obstacles. Using the 4 ultrasonic sensors mentioned previously, UV Clean is able to move around these obstacles, as shown here. UV Clean starts moving forward in the corner of the room until it senses this first obstacle. It turns right to avoid the collision and continues to move forward until the obstacle is no longer sensed on its left side. UV Clean continues like this, going around obstacles and following the perimeter of the room until its sanitation cycle is complete. The circles in these figures represent the UVC dosage given off by UV Clean. As you can see, even with obstacles, UV Clean is able to effectively reach the entire room at its maximum disinfection radius, represented by the larger circles.
The maximum disinfection radius for UV Clean is 6 feet. This means that 6 feet is the largest distance away from UV Clean that will be effectively sanitized. This is an important factor in the sanitation process in small room mode. During small room mode, our robot will be stationary, turning on its UVC light and remaining in place to sanitize the surrounding area. Our team designed UV Clean to kill common household pathogens, such as Salmonella, the flu, staph, and E. coli. Shown in this graph are the time and UVC dosages required to kill each of the targeted pathogens. Given that UV Clean will sanitize for 10 minutes, our device can theoretically kill 99% of the targeted household pathogens from a distance of 6 feet. Unlike small room mode, in large room mode, a distance of 3 feet is the effective sanitation radius, as during large room mode, our robot will wall follow, keeping a distance of 3 feet from objects and walls to avoid collision. Because of this, UV Clean stops to sanitize every 3 feet to ensure effective sanitation. Shown in this graph, theoretically, our robot is able to kill 99% of the targeted household pathogens in under 2 minutes from a distance of 3 feet. With the added maximum disinfection radius of 6 feet mentioned before, UV Clean is able to reach each part of a large room. Our team collected pathogen samples to see if these graphs could accurately describe our device's germicidal properties. In order to perform the testing, various surfaces were sampled and plated on LB agar plates in order to promote pathogen growth. The surfaces we chose were objects that were commonly used and handled. The UVC light bulb was then turned on for 2.5 minutes for testing large room mode, or turned on for 10 minutes to test small room mode. Once the timer was up, the UVC bulb was shut off and the surfaces were resampled and again plated on LB agar plates. Here we can see one example of the results from testing small room mode. We can see a large number of colonies on the pre-sanitation plate, and on the post-sanitation plate, we barely see any colonies. The drastic reduction in colonies proves UV Clean's high germicidal efficiency and ability to kill common household pathogens. These are the results from one round of testing that our team performed. The agar plates shown on the last slide were one dataset belonging to this test. We sampled commonly handled objects in the house, such as phones and a laptop keyboard. Despite not having proper lab equipment for taking samples, our device still showcased an average of 80% reduction in pathogen colonies. We have an amazing team with backgrounds in bioengineering. Matiana Lang has experience with programming embedded systems and sensing technologies. Christian de Guzman is proficient at computer-aided design and SolidWorks. Mary McNeil is skilled in microprocessor design with 8 years of experience in programming. And I, Ethan Santos, specialize in microbiology. Together, we made a perfect team for designing this project. We are UV Clean, bringing you the autonomous UVC sanitation robot. Thank you.
Thank you, Ethan, and the UVC sanitation bot team. I see one question in the question box. How much UVC light on the target surface on the virus? It's a question. I can't quite read the full question, but I think the intent is, what is the energy density per square centimeter in millijoules per square centimeter? Do you guys know what that is?
If I had to guess, I would believe it's referring to COVID-19 and perhaps the required dosage for that.
Okay.
So unfortunately, since COVID-19 is quite new, there hasn't been many studies yet on the UVC dosage required to sanitize coronavirus. However, it is predicted that it would be 5.8 millijoules per centimeter squared based on previous coronaviruses, meaning that UV Clean is predicted to sanitize about 90% of coronavirus pathogens.